Now, for decades, the idea of humanity reaching for the stars felt like a faded relic of the Cold War, a beautiful but impractical dream confined to dusty science fiction novels. We were told space was for governments, for colossal budgets, and for projects that moved at the speed of bureaucracy. And then a company arrived seemingly out of nowhere, not just whispering about the future, but violently dragging it into the present. This isn't about the quaint rockets of yesteryear, or the slow, methodical march of traditional aerospace. Yeah, this is about a company that's not just disrupting an industry, it's rewriting the very rules of what's possible beyond our atmosphere. This is about SpaceX. And as we hurtle into 2026, their ambitions aren't just big. They're audacious enough to sound like a fever dream from a particularly imaginative billionaire. But here's the kicker. They're actually happening. Thus, specifically, in 2026, the entire aerospace world is watching as SpaceX aims to truly operationalize Starship. We're not talking about just another test flight, or even a handful. The vision is for a staggering increase in launch cadence, transforming Starship from an experimental vehicle into a veritable orbital truck delivering an unprecedented volume of cargo and satellites. While this includes the rapid deployment of thousands more advanced Starlink satellites, further solidifying their global internet constellation and funding the very projects we are about to explore. But the big picture extends far beyond low Earth orbit. Whoa! Because by 2026, the foundational steps for human return to the Moon and eventually Mars will no longer be theoretical drawings or distant hopes. SpaceX plans to have multiple Starship variants actively participating in the Artemis program, developing the critical in-orbit refueling infrastructure that's absolutely essential for any deep space journey. Imagine a gas station in space, not just for a single trip, but for building a sustainable lunar presence. This isn't just about reaching the Moon. It's about staying there, about establishing the first true off-world human outpost. And the implications of this dramatic acceleration are staggering, not just for space nerds, but for the entire global economy. It's a gamble, a monumental engineering challenge, and frankly the most exciting show happening on and off this planet. The sheer audacity of SpaceX's 2026 ambitions can only be understood by grasping the incredible transformation slated for Starship itself. This isn't just about launching a Starship, it's about birthing a fleet. Picture Boca Chica, Texas, a place once known for quiet beaches, now a roaring nexus of steel and fire, where these colossal rockets roll off production lines with a pace that would make traditional aerospace engineers faint. The goal isn't just weekly launches, or even daily in some cases, but an unprecedented rhythm that fundamentally redefines humanity's access to space. We're talking about a future where a stainless steel tower, taller than the Statue of Liberty, doesn't just make a single spectacular journey, but becomes a regular ferry, a workhorse hauling gargantuan payloads into orbit and beyond. Oh, what does an orbital truck really mean in practice? It means moving from the limited capacity of previous rockets, which could carry a mere fraction of what Starship promises, to a true bulk carrier. Yaw it like this. If previous rockets were small delivery vans, Starship is an entire freight train. It opens up possibilities that were once confined to science fiction, sending entire modular space stations, massive observational telescopes, or even the heavy machinery needed to begin extracting resources on the Moon or Mars. The sheer volume of this cargo is what makes building a sustainable off-world presence even remotely feasible. It's not just about reaching space, it's about making it economically viable to live and work there. And intimately tied to Starship's relentless launch cadence is the continuous expansion of the Starlink constellation. In 2026, those thousands more advanced Starlink satellites are not just incremental upgrades. And we're talking about a new generation, often featuring sophisticated laser interlinks that drastically reduce latency and increase bandwidth, creating an even more robust and truly global mesh network. These aren't just for providing internet in remote villages, they're the backbone for secure communications, for connecting global markets, and for enabling entirely new industries reliant on omnipresent high-speed data. Every successful Starlink deployment, every new subscriber, pumps vital capital directly back into the very projects we're discussing today, acting as the economic engine for Starship's deep space endeavors. It's a beautifully simple, incredibly effective, and utterly unprecedented business model in the history of space exploration. But the real showstopper, the ultimate test of Starship's deep space utility in 2026, revolves around its role in the Artemis program and the monumental challenge of in-orbit refueling. When for decades, the energy required to escape Earth's gravity well and then make the immense journey to the Moon, let alone Mars, was the ultimate bottleneck. Carrying all that fuel from Earth was prohibitively expensive and limited mission scope. SpaceX's elegant, brutal solution: don't carry it all at once. Launch Starship empty of its deep space fuel, then send multiple propellant tanker Starships to meet it in Earth orbit, transferring hundreds of tons of liquid methane and liquid oxygen. Imagine a gas station, not on some lonely highway, but a precisely choreographed ballet of gigantic rockets hundreds of miles above our heads. This isn't a trivial feat. It demands unparalleled precision engineering, autonomous rendezvous and docking capabilities, and reliable high-flow propellant transfer in the vacuum of space. The development and initial operational tests of this infrastructure in 2026 are not just a technological hurdle, they are the single most critical unlock for truly sustainable lunar exploration. Without reliable in-orbit refueling, a permanent human presence on the moon remains a pipe dream. Why? With it, the lunar surface transforms from a distant destination into a near-term frontier, a staging ground for humanity's next giant leap. It's the difference between a fleeting visit and building a lasting home away from home. The initial steps for Starship's Human Landing System, or HLS, are also taking shape. In 2026, while the full lunar landing may still be a year or two away, the focus will be on testing key systems and components in Earth orbit that directly contribute to the HLS mission. This could involve demonstrating precise navigation systems, validating life support capabilities for extended stays, and proving the reliability of the landing sequence mechanics, all crucial elements for the eventual touchdown on the lunar South Pole. It's a meticulous, step-by-step approach, each successful test building confidence and laying another brick in the foundation of our lunar future. This foundation is not merely for flags and footprints, but for something far more ambitious, a sustained human presence, eventually leading to a permanent lunar base. The ultimate aim for Starship's Human Landing System is not just to drop astronauts on the moon, but to deliver the massive amounts of equipment, habitats, and supplies required to build and maintain a thriving outpost at the lunar South Pole. And think of it as establishing the first off-world town, complete with infrastructure for power, communication, and eventually resource extraction. This isn't just about scientific discovery, it's about establishing an economic foothold. The moon, rich in water, ice, and other valuable resources, transforms from a sterile rock into a strategic reserve, a fueling station for deeper space missions, and a potential manufacturing hub operating in a vacuum and microgravity environment that's impossible to replicate cost-effectively on Earth. Every successful test, every ton of payload demonstrated pushes us closer to this vision. And while the moon presents an immense challenge, it is also the proving ground for the ultimate prize, Mars. The technologies and operational procedures perfected for lunar missions, from robust life support systems enduring extended periods in hostile environments, to closed-loop recycling and the critical ability to refuel in orbit, are all direct precursors for interplanetary travel. Imagine the journey to Mars. It's not just days or weeks, but months in the void. Starship isn't merely a vehicle for this journey, it's designed to be the living quarters, the laboratory, and eventually a crucial piece of infrastructure for establishing the first human settlement on the Red Planet. Future Mars missions won't just carry explorers, they'll carry the means of production, the seeds of a new civilization. This includes crucial systems for in situ resource utilization, or ISRU, technology that will allow future Martian pioneers to live off the land by extracting water from Martian ice or even producing rocket fuel from the planet's atmosphere. While full-scale ISRU demonstrations are further down the line, the data gathered from Starship's performance, its ability to carry increasingly complex payloads, and its robustness in deep space environments are all contributing to the design and testing of these life-sustaining Martian technologies. This isn't just about exploring space, it's about industrializing it. The Starship is the ultimate disruptor, promising to transform space from a government-led endeavor costing billions per mission into a more accessible, commercially driven enterprise. This shift has profound economic implications. About orbital manufacturing, where unique materials and products can be created in microgravity without Earth's atmospheric constraints, leading to breakthroughs in pharmaceuticals, advanced alloys, and semiconductors. Consider space tourism, not just for a fleeting suborbital hop, but for true orbital stays in large modular space hotels delivered by Starship, and eventually the mining of asteroids for precious metals or water ice. A concept that once belonged purely to science fiction, now inches closer to economic reality thanks to Starship's unprecedented payload capacity and cost efficiency. However, the path to this future is not without formidable hurdles. The 2026 ambitions, as audacious as they are, rely on an almost flawless execution of a series of highly complex, interdependent technological leaps. The challenge of mass-producing starships at the required cadence while maintaining rigorous quality control is immense. Every launch and landing, every in-orbit refueling attempt is a high-stakes endeavor with inherent risks. The sheer reliability needed for a fleet of human-rated starships to operate continuously and safely is a monumental engineering and operational undertaking. Furthermore, the regulatory environment for such a rapidly expanding, globally impactful space industry is still evolving, posing its own set of challenges. But even beyond the technical aspects, managing the vast capital requirements, navigating potential geopolitical complexities as space becomes more accessible, and ensuring the long-term sustainability and safety of orbital environments are all critical considerations. What SpaceX is attempting is not just to build bigger rockets, but to fundamentally rewrite the rules of space access, creating a new economic frontier. It's a gamble of epic proportions, but one that promises an unprecedented return, nothing less than humanity's future amongst the stars. This epic gamble, however, is not played on a whim. It is underpinned by a deeply unconventional yet strategically brilliant approach to engineering and enterprise. SpaceX's core philosophy is one of rapid iteration and vertical integration, a stark contrast to the decades-old, often sluggish aerospace industry. Instead of meticulously designing for perfection over years, then building, they build, test, and often fail, then learn and rebuild, all at breakneck speed. Now, this fail fast, learn faster methodology is not merely a slogan. It is the engine driving Starship's development, dramatically compressing timelines and slashing costs. Every explosion on a test stand, every anomaly during a flight provides invaluable data, accelerating the path to a robust, reliable, and reusable system. Yet this accelerated development is made possible by an equally disruptive economic model. Unlike traditional aerospace contractors largely reliant on government contracts, SpaceX has diversified its revenue streams. Starlink, their satellite internet constellation, is rapidly becoming a significant cash cow, generating billions and effectively self-funding a substantial portion of Starship's colossal development costs. This entrepreneurial symbiosis allows SpaceX to pursue audacious long-term visions, like Mars colonization, without solely being at the mercy of government budget cycles or short-term investor demands. And the regulatory environment, often seen as a bureaucratic quagmire, is also being navigated with a similar innovative spirit. While undoubtedly complex, SpaceX actively engages with agencies like the FAA and NASA, not just to comply, but to help shape the future of spaceflight regulations. As a pioneer, they are effectively writing the playbook for an entirely new era of rapid commercial space operations, pushing for frameworks that support innovation while ensuring safety and environmental stewardship. This isn't about sidestepping rules, but about working hand in hand to evolve them for a future where space launches are as routine as commercial air travel, albeit with infinitely more power and complexity. So, the ambition isn't just to build a rocket, it's to build the entire operational and regulatory infrastructure necessary to support an off-world economy. Looking beyond 2026, the implications of Starship's maturation extend far beyond simply moving cargo and people. It's about unlocking entirely new markets and economic paradigms that are currently unimaginable or prohibitively expensive. Consider the concept of Earth-independent industries. Imagine manufacturing specialized pharmaceuticals or advanced materials in microgravity, then delivering them to Earth at costs that make them competitive. Or the advent of truly scalable space-based solar power, transmitting clean energy back to our home planet, fundamentally altering global energy markets. So, these aren't just incremental improvements, they are foundational shifts that could create trillion-dollar industries, drawing in vast amounts of capital and talent, creating jobs and economic opportunity on a scale not seen since the Industrial Revolution. The Moon, in this grand scheme, is not merely a scientific outpost, but a critical proving ground and a vital fueling station. Its abundant water ice, when refined, can yield both breathable air and rocket propellant, enabling missions deeper into the solar system without the immense cost of lifting all fuel from Earth's deep gravity well. This in-situ resource utilization, or ISRU, is the ultimate game-changer, transforming the Moon into an active participant in space commerce, a waypoint on the interplanetary highway. Starship is the delivery mechanism, the heavy-lift workhorse that makes the equipment for ISRU economically viable to transport, install, and operate. The vision is clear: to create a self-sustaining cislunar economy, a vibrant ecosystem stretching from Earth orbit to the lunar surface, before making the leap to Mars. This isn't just about escaping Earth. It's about expanding humanity's economic sphere and securing a future beyond the limitations of a single planet. The risks are astronomical, the challenges unprecedented, but the potential rewards, a multiplanetary civilization and an entirely new economic frontier, are even greater. It's a story of audacious engineering, relentless pursuit, and the unwavering belief that the greatest chapters of human history are yet to be written, not on Earth, but among the stars. And so, when we look back at this pivotal era, what truly resolved the seemingly insurmountable conflicts of reaching for the stars was not a single breakthrough, but a radical reimagining of the entire human endeavor in space. It was the audacious gamble on reusability, born from the fail-fast, learn-faster philosophy, that slowly but surely began to dismantle the prohibitive costs and technical barriers that had plagued space exploration for decades. Every test, every launch, every landing, successful or not, chipped away at the unknown, transforming theoretical physics into operational engineering. The financial conflicts, the endless budget battles that once stifled innovation, found their surprising resolution not in government coffers, but in the entrepreneurial spirit of a new space economy, fueled by ventures like Starlink. This created a self-sustaining loop where commercial success on Earth directly funded the expansion into the cosmos, untethering destiny from political whims. The bureaucratic quagmire, the regulatory maze that could crush ambition, found its resolution in proactive engagement and collaborative pioneering. All agencies and innovators, initially wary, began to forge new paths together, creating the very rulebook for an interplanetary future as they went along. This wasn't about defiance. It was about evolution, ensuring safety and responsibility while simultaneously unlocking unprecedented speeds of development. Ultimately, the grand historical significance of Starship and the enterprise it represents isn't just about building a bigger, better rocket. It's about a fundamental reorientation of humanity's economic and existential priorities. For centuries, our prosperity, our conflicts, our very existence have been defined by the finite resources and boundaries of a single planet. Starship, by promising truly abundant, low-cost access to space, fundamentally shifts that paradigm. It makes the impossible accessible, turning science fiction into economic strategy. Consider the sheer weight of this transformation. We are witnessing the dawn of an era where humanity's economic engine begins to encompass an entire solar system. The moon is no longer just a distant celestial body for flags and footprints, but a quarry, a gas station, a proving ground for an off-world civilization. Mars transitions from an unreachable dream to a tangible frontier, a second home for a burgeoning multiplanetary species. The implications are profound, reverberating back to Earth with unimaginable force. New industries will blossom, creating wealth and opportunities that transcend current definitions. Resources from asteroids, energy from space-based solar arrays, unique manufacturing capabilities in microgravity, these aren't distant fantasies anymore. They are the emerging economic sectors of tomorrow, facilitated by the reliable, frequent, and affordable transportation Starship promises. It promises not just new markets, but entirely new kinds of markets, reshaping global power dynamics and fostering unprecedented collaboration across nations. This is the ultimate legacy, the irreversible expansion of the human domain. The conflicts weren't just about engineering or economics. They were about a species grappling with its own limitations, its own perceived boundaries. Starship is the tool, the catalyst, for breaking those bonds. It represents a bold declaration that humanity's greatest chapters are not just about survival on Earth, but about thriving beyond it, expanding our consciousness, our economies, and our very future into the boundless expanse of space. It's a story of audacious vision finally taking flight, an irreversible trajectory towards a multiplanetary civilization, driven by the ingenuity and relentless spirit of those who dared to look up and build a highway to the stars.